I'm going to give you just a quick introduction to oxidation reduction reactions. That's where electrons are transferred from one reactant to the other. That does not happen when we have just an exchange reaction, because everything, we just got 4 ions that combine together. Okay? But if we have an element that forms a compound, or a compound that forms an element, electrons had to be transferred, because we could go from a neutral to a charge, or a charge to a neutral, or something like that. Okay? So anytime the charges are changing, we have to do oxidation reduction. Okay? We use oxidation numbers to keep track of electrons in a reaction. They're very similar to charges. Okay? But they even work for neutral molecules. I'll show you how in a second. But if you think of oxidation numbers the same way we've been thinking about charges all along, that'll get you almost all the way there. Okay? So oxidation numbers, they're just sort of a way of keeping track of the electrons. Okay? So elements, the oxidation number of an atom in an element is 0, just like its charge. Pure elements are uncharged, okay, and have no charge. Okay? So regular plain old elements, right? If we had just, sodium, okay, that is a oxidation number of 0. Okay? Monoatomic anions, okay, oxidation number equals the charge. So if I had Na+, that oxidation number is +1. Oxidation numbers are actual integer numbers. Okay? So we can talk about +1, -1, things like that. Okay? So oxygen is usually -2, just like oxygen's charge. Okay? A couple of exceptions there that you should look through that you may run into from time to time. Pretty much you can assume oxygen is -2 when it's in a compound, but when oxygen is an element, it's 0, just like every element. Okay? Hydrogen is usually +1. There are a couple of exceptions to that. Halogens, okay? Halogens are usually -1, just like their charge, unless they're combined with another halogen. Okay? We'll show you a quick example how that works a little bit later on. Okay? And then overall for compounds and ions, the sum of the oxidation number in a compound is 0. Because compounds are neutral overall, we should be able to add up all of these oxidation numbers and get 0 for the whole compound. Okay? If it's a polyatomic ion, all of those oxidation numbers should add up to the polyatomic ion's charge. Okay? So let's take some of these rules here. What is the oxidation number of sulfur in Na2SO4? Well, let's look at this. This whole thing is a compound. Okay? So overall, the sum of all of those oxidation numbers will be what? Yeah. Overall. Okay. I mean, yes, but it's not really a memorization thing. I mean, think of it in terms of charges. Think of it the same way you would think of charges. Okay? I mean, look at it. You don't need to memorize those exceptions in that chart, but you should be very familiar with how all these things work. Okay? But I don't want to tell you to just memorize this chart, because that's, that's making it harder than it has to be. In other words, okay. So overall, the sum is going to be 0. Okay. Let's break this apart, though. Right. This is an ionic compound. Right. So what charge do those sodiums have? Yeah. Sodium. So we've got essentially 2 Na+. Okay, and we've got SO4 2 minus. Okay. So got 2 of those. I mean, that's sort of looking at the compound overall. You can say 2 of those +1s for those sodiums. Okay. S as sort of a variable. Okay? And then I've got 4 of those O's. What kind of charge does O have individually? Yeah. Right? So 2 plus S minus 8 equals 0. S equals 6. Let's call it plus 6. Okay? So if your job is ever to determine the oxidation number of some element in a compound, okay, start with those kind of known oxidation numbers, right? Oxidation numbers of ions, of hydrogen, of oxygen, of halogens. Okay? Why don't you see if you can figure out what P is in P2O5? Set that up like a little bit of algebra using P as a variable. It's a compound, so you know what the whole thing will sum up to. Make this look a little more like an S and less like a 5. If you need a hint, I would start writing it sort of like that. So I want to know what phosphorus is. That's sort of the variable in this. We're going to use the other element and the sum. P2O5. What's oxygen's number? Negative 2. And summing together, this is a neutral compound, sum will be 0. Okay. Anybody get a answer? Yep, plus 5. Okay. That's how you determine an unknown oxidation number. Okay. Now, what this is useful for is to identify whether something in a reaction gained or lost electrons. Okay? An oxidation is a loss of electrons. Okay? And because electrons are negative, if something loses electrons, its charge and its oxidation number will increase. Okay? Reduction means we're gaining electrons. Okay? We're going to get more negative then, so oxidation number decreases. It becomes more negative. Okay? There's a couple of very helpful little mnemonics that help you remember that. I always was taught about Leo the lion that says grr. Right? Loss of electrons is an oxidation. A gain of electrons is a reduction. And still to this day, sometimes I say Leo and grr in my head. Okay? The other one I've heard is oil rig. Oxidation is loss, reduction is gain. And the great thing about that, the funny thing about that, I suppose, is that Leo and grr, the one talking about the lion, is what almost every chemist has heard through their training. And oil rig, the one involving petroleum hydrocarbons, is the one almost every biologist has heard in their training. So I don't know why, but whatever works for you. So that's what an oxidation and reduction is. However, the major complication here is that an oxidizing agent is something that causes something else to be oxidized. And when it causes something else to be oxidized, it itself has to be reduced. Okay? So whenever this agent is involved, it's just pretty much the reverse. Okay? So agent is a reversal. But that's really useful because we don't usually think about whether the thing that we have was oxidized or reduced. Okay? We think about what we need to add in order to make something get oxidized or reduced. Okay? So let me just give you two examples right here. To figure out what's being oxidized and reduced here, let's write oxidation numbers. Hi, we're almost done. A meeting starting here? Okay. This is an ITV room. Yeah, that's weird. The elements have oxidation numbers of 0, right? Sodium is +1, chlorine is -1. All right. Did that sodium gain or lose an electron? Yep. Gain electrons is reduction. Did that chlorine? No, that didn't gain an electron. Yeah, that's Leo. All right. Did this chlorine gain or lose an electron? It went from 0 to -1. Okay, there we go. So sodium is oxidized. Cl2 is reduced. Okay. Which of those is the oxidizing agent? Okay. Chlorine is the oxidizing agent. We add chlorine to pools and laundry, right, and bleach, because it causes the contaminants, the other stuff, to get oxidized. Okay? It oxidizes those other things. But in doing so, it itself is reduced. Okay? Okay. In a problem like this, we get sodium and chlorine making sodium chloride. Okay? To figure out what was oxidized and reduced, we applied oxidation numbers to each of the elements in this. Okay? What made us write zeros for the sodium and the chlorine over there on the left? The what? Yeah, they're just elements. Whenever we have a pure element as a reactant or product, its oxidation number is 0. 0 overall and 0 for any elements inside of it if it's a molecular element like that. Okay? So just elements are 0. But here we have sodium chloride, a compound. Okay. And if you've got ions, right, if you've got an ionic compound, the oxidation numbers of those ions are just the same as those ions, what? Charge. Yeah, they're charges. Na is plus, Cl is minus. Okay? So then you track one element from one side to the other side. We went from 0 to +1 for sodium. We went from 0 to -1 for chlorine. And we think about how adding or removing electrons would cause that number to change. Okay? Keeping in mind electrons are negative. Okay? So why did we say Leo there for sodium, going from 0 to +1? Mm-hmm. Yep. If sodium starts out 0 and loses an electron, it's going to become more positive because electrons are negative. Okay? Sometimes it's easier to think about the gaining side. If we start at 0 with chlorine and it gains an electron, it becomes negative. Okay? So this is an oxidation-reduction reaction, and you have to have one of each. You have to have one oxidation, you have to have one reduction, because the electron that the oxidation is losing, that's the very same electron that the reduction is gaining. Okay? It's a transfer of electrons from one thing to another. Okay? So it's that sodium that had an extra electron, it gave it to the chlorine, okay, for the chlorine to become minus. So sodium was oxidized because it lost an electron. Cl2 is reduced because it gained an electron. But because chlorine was reduced, that makes chlorine into the oxidizing agent. Because chlorine itself was reduced, it caused the sodium to be oxidized. So chlorine's role was to cause the oxidation of the other reactant. That's what makes it the oxidizing agent. So,
You have like a diatomic, like hydrogen,
Mhm.
and you're creating like hydrogen gas or H2.
Mhm.
Would that hydrogen be both of them then?
If you have H2 gas, that's an element, so that's 0.
Oh, it's still kind of.
Mhm. Yep.
Okay.
Yep. So,
If you had like 2H, and then that. Because I was just looking at the lab that said like, then that equation just had 2H yielded H gas. So.
well,
I'm not sure how to write that.
yeah, because you're probably having zinc and HCl
Yeah.
making, right? And those will get split up, right? And the chlorine becomes the, right, I got 2 HCl, okay? Chlorine becomes the spectator ion, okay? But the thing is here, HCl, because that splits up into ions, that's not neutral H. What charge does that H have inside of HCl? Yeah, that's H plus. So for that, we'd be going from 1 plus, or plus 1, to 0.
So is it just reduced then?
Yep. So plus 1 to 0, that would be a, what is that? Is that a gain of electrons or a loss of electrons? Yep, that's a gain of electrons. It's making it more negative. So that's a reduction. So what's the oxidation that had to happen here? We got zinc that's just an element over here. What about the zinc that's part of zinc chloride? What's that? Yeah, that's plus 2 because it's an ion.
So it was left over.
Mm-hmm. Yep. Yep. So two things do not cancel out. They're not spectators if their charge changes. Okay? They're only spectators if they stay the same. So Cl minus is a spectator here, right? You'll have 2 Cl minuses on the left and the right. But zinc is not a spectator. Zinc goes from neutral zinc to zinc plus 2. Okay? So that's a good question. Anybody else have questions about how that sort of thing behaves? So you really need to know your difference between your elements and your compounds. Okay? If you've got an element, everything's going to be 0. If you've got a compound, it's going to be pluses and minuses inside of that compound. Okay? Let's do one more example here on the bottom of a combustion reaction where it's an oxidation reduction. O2 is a reactant. Okay? Oxidation comes from oxygen. Okay? And we'll be able to talk about what role oxygen serves in reactions like these. We already know that combustion reactions with carbon-containing compounds form CO2 and H2O because that was our combustion analysis from the last chapter. Let's start with C6H6 for a coefficient. And if I want combustion of C6H6, what's the other reactant going to be? Yep, O2. And then the products are CO2, H2O. Okay. Should balance it, I suppose. 6 and 3, but that looks odd. So I have a feeling I'm going to need to do 2, 9, 12, and 6. Is that right? No, not 9. 15. I was adding wrong. 12 times 2, so 24 and 6, so 30, so 15. Yep. Let's see if that's right. 2, 15, 12, and 6? Yep. Okay. But what this question really is about oxidation and reduction. So let's figure out the oxidizing and reducing agents and oxidation numbers of pretty much everything within this compound. Okay? So let's start with C6H6. It's a compound, so whatever numbers we have inside of that will have to add up to what? They'll have to add up to 0. Okay? I gave you a little hint before last time about what H usually is. It's what charge that first column of elements usually is. So what do you think that is? First column of elements all on the left. Lithium, sodium, potassium, they always have what charge? +1. Okay? So the oxidation number of H will typically be that as well. So let's start with that. Okay. So if H is +1, like it usually is, okay, only time it's not is when it's paired with a metal. Okay. But we don't encounter that very often. So what would C have to be in this compound? -1. Yep. You'll have 6 pluses, you'll need 6 minuses for it to add up to 0. Okay? So I got that. What about O2? It's an element, so 0. Okay. Now here we got C. That can be sort of whatever, okay? But what did we say O usually is when O is in a compound? -2, okay? So if you think of that, -2, and you've got 2 of them in there, what do you suppose this C has to be? Yep, that's going to be +4. Okay. I suppose this H is over here. That's what H usually is. It's going to be +1 because that O is going to be -2, and that'll add up. 2 pluses, 2 minuses. Okay. So, what is the element here that did not change in its oxidation number? Hydrogen remained +1. Okay. So that's fine. No change there. Okay. But then we can track those other two because their oxidation numbers do change. Carbon goes from -1 to 4. Okay. Is that a loss of electrons or is that a gain of electrons? Yep, that's a loss of electrons. Gaining of electrons makes it more negative, right? Loss of electrons makes it more positive. So the other one is O, from 0 to -2. Is that a loss of electrons or gain of electrons? Okay. All right. So what was oxidized here? Carbon was oxidized. O was reduced. Okay. What is the oxidizing agent? O2. Okay. For these agents, we usually write it as the whole compound itself. Reducing agent, we're going to write C6H6. Even though H didn't change, okay, we're going to write the compound that contained the thing that got oxidized. Okay? So that's where the term oxidizing comes from. Okay? Oxygen itself gets reduced, okay? But oxygen is an oxidizing agent. When something is exposed to oxygen, it gets oxidized. Okay? So the oxidize reduce, that's you know, the oxidation of C6H6 was helped along by the oxygen. Okay? So that's a way to think of it. Typically, metals and things, when you set them out in the oxygen, they get oxidized. That's what happens to them. So that's where all that kind of terminology comes from. It's not because oxygen gets oxidized. It's because oxygen is there when other things get oxidized. Okay? I was just about to close the ticket on this screen blanking out. I'm glad I didn't. Metals undergo combustion to form metal oxides. Let's talk about combustion of zinc. We could write any metal here. Okay? So combustion is always something plus O2. What will be the formula of the metal oxide that's formed over here? Yeah, it's going to be ZnO. Why not ZnO2? Yep. Got to think of those charges. We can write them for oxidation numbers too. Okay. Where's the oxidizing agent here? That's a couple of steps of abstraction, but you can see the pattern from the last one, too. Just like the other one, O went from 0 to minus 2. Okay? So again, O2 is the oxidizing agent. Okay? Oxygen is an oxidizing agent. Chlorine is a common oxidizing agent. I think I mentioned last time the reason you can put bleach in your laundry or in your pool or something like that is because it causes the other contaminants to become oxidized. Okay? So that's how all that works.
So when you write
Yes?
the reducing agent, like CM, would you always write CM or CM?
Nope. The agents are always the reactants. Okay? So Zn is the reducing agent. We're thinking about, okay, I've got something, I need that to be oxidized. What am I going to add into it? Okay? So zinc is a common reducing agent for things. It causes other things to become reduced. Oxygen is a common oxidizing agent. It causes other things to become oxidized. When iron rusts, okay, it forms iron oxides, okay, because the iron has been oxidized. But oxygen is the oxidizing agent. Okay. All right. So, other questions about that? We good with those? All righty. Let's finally start gases.